In the figure above, equilateral triangle ABC is inscribed in the circle. If the length of arc ABC is 24, what is the approximate diameter of the circle? So what information do we know? So first we are given an equilateral triangle, and I like that. I'm always looking for equilateral triangles because equilateral triangles give you a lot of information. Usually it is information that is intended to make your life easier. And so when they straight up give me an equilateral triangle, I like that. And so if this is an equilateral triangle, we know all of its angles are the same measure. So each of these are going to be 60 degrees because they got to add up to 180. We also know each side of our equilateral triangle should be the same length. So that's worth noting. They also tell us ABC, arc ABC, has a length of 24. And so ABC, so starting from A and then going all the way around to C. So that's from A to B, then from B to C. We know that is 24. And then from that, we got to get the diameter of the circle. So how can we relate these two things? We got the angles of our triangle, and then we know the length of this arc from A all the way to C. And so how are these two things related? And maybe we'll just use this one angle. Angle A is an example. So each of the angles in our triangle here is an inscribed angle, which maybe you could infer from the fact they tell you that the triangle is inscribed in the circle. And so an inscribed angle has all three of its points on the edge of the circle. And so this here was 60 degrees. And the reason inscribed angles are valuable because every inscribed angle should have a corresponding central angle. And so a central angle is going to start and have 2 points that are the same as its corresponding inscribed angle, but then instead of going all the way to the opposite edge of the circle, these are going to converge in the center of our circle. So a central angle is made up of 2 radii. And the relationship between inscribed angles and central angles is your central angle should always be twice its corresponding inscribed angle. And so what do we know here? So here we used angle A as our example, but given that all of 3 of our angles are inscribed angles, they should all have corresponding central angles that are the same, that are also 120 degrees. And every central angle corresponds to a certain arc. So for example, this central angle here corresponds to arc BC and could use to calculate that arc length. So given that we have the same central angle for all 3 of our arcs here that make up this circle, all 3 of these arcs should be the same length, and we can call that x. And so we know ABC, so that's AB plus a BC is 24. But since these are equivalent, we know each of these is 12, and then we also know that from C to A is also 12. So from this, we have the full way around our circle. And so this is actually our circumference, right? So we know our circumference, and that is pi d, right? 2 pi r. That should be equal to 36. And so we're looking for the diameter. So our diameter should just be 36 over pi. It says approximate. And so that's worth noting. And so based on this, so we know pi is a little bit more than 3. And so this is really like saying 36 over something a little bit more than 3. So if 36 over 3 is 12, 36 over something a little bit more than 3 should be a little bit less than 12. 11 seems like a good choice. C.